This is a continuation of 4.1, where we ended up by rationalizing a denominator. And it was explained that you cannot leave a radical in the denominator, so you choose a giant 1. And if you notice right here, it gives you a big hint. It says you use the square root in the denominator to find the appropriate form of the giant 1 for the multiplication. So that's just a reminder of rationalizing a denominator. But the binomials a square root of b plus c square root of d and a square root of b minus c square root of d are called conjugates. If you look at them, they're exactly the same except for the sign in the middle. The sign is opposites. You can use conjugates to simplify radical expressions that contain a sum or difference involving square roots in the denominator. So notice it says there's an expression containing a square root in the denominator. So we'll get to that in a minute. So here's showing you again how to find a conjugate. Notice it's just the middle sign that's different. Everything else stays the same. And this is just reminding you that a binomial is a term that has an expression that has two terms, one with a radical. So here's some more expressions turned in, and they're conjugates. So you can see it's the exact same, just the middle is different. Okay, so here we're going to learn how to rationalize the denominator using conjugates. So the conjugate becomes the basis for our giant 1. So the first thing you do, you don't have to draw the square, I just do. You could just remember. But the first thing you're going to do is put the conjugate in the denominator, okay? So there is my conjugate. Now to be 1, it has to be the same in the numerator. So now I've put my conjugates in there. I put parentheses around my expressions, and now I'm going to multiply. So in this case, I'm going to FOIL. So I'm going to go 2 times 2 is 4. 2 times the square root of 3 is the 2 the square root of 3. Negative square root of 3 times 2 is minus 2 square root of 3. And then negative square root of 3 times positive square root of 3 is negative square root of 9. Now notice we've pulled all those rules together. The square root of 3 times the square root of 3 is 9. These cancel each other out. That is the whole point behind that conjugate. And then we get 4 minus the square root of 9 is 3. So our denominator is 1. Doesn't always come out that neat, but that's the way it is for this one. And then for this one, we're going to distribute, so we get 14 plus 7 square root of 3. And so the final answer is 14 plus 7 square root of 3. You don't need to leave it over 1 anymore. So now we're going to do some practice with not just the conjugates, but just rationalizing denominators. So the first one, you want to first see if you can simplify. So I know that the square root of 15 is square root of 5 times the square root of 3. And the square root of 500 is the square root of 5 times the square root of 100. And I went ahead and already separated them. This started out, with them together. And now I can cross cancel. So I end up with the square root of 3 over 10. And that is my final answer. So don't think you have to be tricky to do this. You just simplify to start. Okay, if you look at this one up here, again, we can simplify. We've got the y cubed is going to take care of the y cubed. This x takes away one of those x's. So now I'm left with 3x over 80. But I know that 80 equals 16 times 5. So this is 3x over 16 times 5. So I get square root of 3x over 4 square root of 5. Now that we're here, when you're using the conjugate here, you only multiply by the radical portion. So my giant 1 would be the square root of 5 square root of 5. Otherwise, you just have to simplify later on. So this becomes the square root of 15x over 4 times the square root of 25, which is 4 times 5, which is 20. And that is your final answer. Okay, so for this one, we're going to use the conjugate. I'm going to go ahead and write it up here. So my conjugate is still -3. I only change the center sign. So make sure you remember that. You don't change everything. Okay? And then the top has to be exactly the same. So I'm going to go ahead and do my denominator first. I get -3 times -3 is +9. -3 times 3 square root of 3 is -9 square root of 3. -3 square root of 3 times -3 is +9 square root of 3. And then the last one is -3 times -3 is -9 square root of 9. The numerator is -15 plus 15 square root of 3. So now I'm going to go ahead and cancel those, and I get 9 minus 9 times 3, which is 9 minus 27, and that equals -18. Okay? So my denominator equals -18. So now I can go a bit further, and I can simplify this. Okay, if you think about it, I've got square root of 15 plus the square root of 15 square root of 3 over -18. And right away I can see that I can factor out a -3. So I factor out a -3, I'm left with, whoops, I don't want a radical there, so I've got to erase that. I just want parentheses. So I've got a 5, and then make sure when you factor out you get the opposite sign, 5 square root of 3, and that would be over -3 parentheses 6. So now I'm going to cross cancel the -3's, and my final answer is 5 minus 5 square root of 3 over 6. And that would be the final answers that you get. Okay, this is 2 more from your extra practice. If you want to try this yourself, go ahead and push pause. Otherwise, we will get going. So again, I'm going to use my conjugate, and I'm going to start with the bottom, opposite sign, parentheses, put parentheses here, and then square root of 3 minus square root of 5. Always double check that you've put the same on the top and the bottom. And now I'm going to do my numerator, so I get the square root of 3 times 5 is 15, minus the square root of 5 times 5 is 25. And I'll simplify that in a minute. I'm going to go down here. I'm going to go square root of 3 times the square root of 3 is the square root of 9, minus the square root of 15, 3 times 5, plus the square root of 15, 3 times 5 again, minus the square root of 25. So those cancel. I get 3 minus 5, because the square root of 9 is 3, square root of 25 is 5, and then I can't simplify in the first one, but I can get square root of 15 minus 5 over -2. And I am done with that one. Okay? So the ratio of the length to the width of a golden rectangle is this. The length of the golden rectangle is 62. What is the width? So I'm going to set up this ratio. I'm going to cross multiply. So this is x, sorry, that's x. I'm going to cross multiply, I get x parentheses 1 plus square root of 5 equals 2 times 62 is 124. And then I'm going to divide both sides by 1 plus square root of 5. And that's what equals x. So now I need to simplify this. So I could just find the values now, but I'm going to go ahead and simplify. So 1 minus square root of 5, 1 minus square root of 5, and I get 124 minus 124 square root of 5 over 1. So this will be 1 times 1, then 1 minus square root of 5 plus square root of 5 minus square root of 25. So we'll cancel those. We get 1 minus 5. Okay? So now what I'm going to do is I get 124 minus 124 square root of 5 over -4. But this tells me they want the answer to the nearest meter. So 124 minus, and I multiplied the square root of 5 is approximately 2.236. So I'm going to go ahead and multiply that, and that is times 124 is 277, and that's over negative 4. So that becomes negative 153 over negative 4. Cross cancel those negatives, and it's approximately 38 meters. And those are the answers you get for these two problems. Okay? So go back and review them if you're not sure what you're looking for. Okay, the last problem we're going to do is solving a real-life problem. So the distance in miles that you can see to the horizon with your eye level h feet above the water, so they told you right here that h is 5, is given by d equals the square root of 3 times h over 2. So if your eye level is 5 feet above the water, how far can you see? So you go distance equals the square root of 3 times 5 over 2 equals the square root of 15 over the square root of 2. So I'm going to rationalize this. I get the square root of 2 over the square root of 2 is the square root of 30 over 2. But that's not really an answer because that's not telling me if someone asked you, how far can you see? You wouldn't say, oh, I can see the square root of 30 over 2. Nope, you're going to calculate it out, and it comes to approximately 2.74 miles. And there you go. So that's all for today. We're going to finish up 4.1 tomorrow. Have a great day.